Welcome to the Real Python Podcast. This is episode 140. How can you get more performance from your existing data science infrastructure? What if a DataFrame library could take advantage of your machine's available cores and provide built-in methods for handling larger than RAM datasets? This week on the show, Liam Brannigan is here to discuss polars. Liam is an experienced data scientist working in finance, technology, and environmental analysis. He's recently started contributing to the documentation for polars and developing a training course for the library. We talk about the library's overall speed and lack of additional dependencies. Liam explains the advantage of lazy versus eager mode and which to choose when performing data exploration or attempting to load a dataset larger than your RAM. We also discuss potential barriers to switching to polars from a pandas workflow. Across our conversation, we explore several other libraries and technologies, including Apache Arrow, DuckDB, query optimization, and the rustification of Python tools. This episode is sponsored by Anaconda Nucleus. With nothing to install and nothing to configure, Anaconda Notebooks is a fully loaded data science environment entirely in your browser. Start coding in the cloud on anaconda.cloud today. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Liam, welcome to the show.
Hey, Christopher. Thanks for having me on.
Yeah, you had reached out to me earlier in the fall, and sorry for the delay on getting you on the show, but I am very interested in this topic. I've heard about polars a little bit, and I've definitely heard about Apache Arrow, having talked about it a little bit in previous podcasts with Christopher, kind of covering some of the changes and updates in the data science world. And so I'm very excited to talk about both these things. Maybe you can give me a little background about you and your involvement with polars.
Sure. My background is actually as an environmental scientist.
Oh, cool.
I did my PhD in physical oceanography in Oxford, finished up a few years ago. Then I was a postdoc for a few years and got a bit tired of academic instability. So I became a data scientist at a Belfast-based startup here in Northern Ireland called Analytics Engines, became the lead data scientist there. And then last year, I started my own company to do data science consultancy and also training. And so I was doing a training workshop for actually some oceanographers in Ireland at the Marine Institute. And I was training them how to use pandas. And I was finding that I was having to teach them all these little sort of tricks that you need to do with pandas to actually make it run a lot faster than the defaults.
Yeah.
And then I started to show them, there are some other options out there. There's things like DuckDB, and then there's this polars library. And I showed them polars and how fast it was. And then somebody was like, why don't we just use polars if it just works fast rather than learning like these 1,000 different tricks you've taught us about using pandas? So then I thought, that's a pretty good idea.
Yeah, I wonder about that too. Like, are there things, I guess that'll kind of be some of the focus that we get into here. Are there things that get in the way of just switching out to a whole new library? Is it partly just how much of the data science community is currently using pandas only? Is it easy to switch something like, that? I'm wondering what hurdles are there.
Yeah, so I've been thinking about this recently about what are the kind of the barriers to and the kind of push factors for adoption of a new DataFrame library.
Yeah.
And so there are little barriers, like the syntax is a little bit different. You have things like using expressions in polars, which is the way you kind of build out your queries. And that's a little bit of unfamiliarity. But once I started using it 6 months ago, I basically stopped using pandas overnight because I found that the way you write things in polars just maps much more to how these things sit in my brain.
It's doing the same for mine. I really got a chance to dig in yesterday. I was telling you right before we started, and I'm like, oh, these are like making so much more sense to me, just the grouping. And I think I've mentioned multiple times how I'm a fan of R and how it's kind of laid out. And I'm thinking there's some weird concessions that went into creating pandas, and it is like a legacy thing, I think, for certain elements of it, which make it kind of interesting.
Yeah, so I think the thing about pandas is that it was really the trailblazer. It really got things going and really had to like solve all these problems for the first time. And I feel like for the new generation of things coming through, that if you're starting with a blank sheet of paper, you have a chance to kind of take in a lot of the great things that pandas have done, but also learn some of the lessons and start without having that kind of legacy holdover.
Yeah. And you're working pretty hard on getting people up to speed with it. You have a lot of resources on your blog, and even a nice cheat sheet, which I always enjoy, not having to dig through an entire article to find things I'm looking for.
Yeah, so someone got in touch. There's a Discord server for Polars for if you want to get in touch and talk about ideas about how the library works or kind of some of the kind of concepts that underlie it and where it's going. And somebody sent me a message and saying, hey, I'm just always looking for a cheat sheet, and I know you like to write about Polars, so why not do that? And I thought, wow, that's a great idea. And I can see from my analytics that, yeah, people are definitely looking for that. That's something that's handy for them.
They're popular.
Yeah.
Yeah. And then you do a bunch of content on YouTube, and we'll definitely include links to that. But the other major thing you've been working on is a course.
Yeah, so I've released a course on Udemy. I got so excited by this over the summer. I just found that everything was just, I guess, the first project I started using Polars on, that I had a large CSV that I was doing some kind of exploratory data analysis on. So I needed to load the whole data set in and be able to just like randomly sample it and check out what's happening in the data. And the first day I started using Polars, that I loaded in the CSV, just, called read CSV. And normally in pandas that it took about a minute or so for that CSV to load. And so I would get distracted and I'd open up Twitter and kind of do things like that.
Right.
And the first day I did in Polars, I went to open up Twitter and I realized that with this, after just a couple of seconds, that it was already loaded. I was like, oh, okay, that was fast. Like, I guess I don't get my little bit of distraction time, but what that really means is that you're kind of keeping your flow, that you're not having all these little like 1 minute, 2 minute gaps. If you got something which works fast for that kind of thing, because I talk to some people and they say, oh, I don't really need Polars because performance isn't a constraint. And when I try to explain that it's not just about whether you've got some huge cloud computing bill that you need to get under control. It's about whether you can kind of keep up your flow by taking all those little gaps and just getting rid of them because the computer is just working a lot more efficiently on your query.
Yeah, I noticed that too, just like little minor speed improvements that were noticeable. And I've talked about that a lot too. Like as a musician, I often use tools that allow me to continually have the music application, digital audio workstation, whatever, be able to continue to play while I'm editing and modifying things. And so it's not a constant like stop, go back to the beginning. Where do I want to start from? Just like let it loop and keep going around. And I feel like sometimes that's how a lot of data scientists are working on things. And if they can kind of stay in that flow, especially when it becomes a bigger data set where it normally would require coffee breaks in between, that's really cool.
Yeah, and kind of related to that, one of the kind of key parts of the API is that there's no kind of index in Polars. And what I found, if I have to go back and write some pandas code, is that I'm spending a lot of time just managing that index.
Yeah.
And once you realize you don't need to have it, you're just like, why is it my job to deal with all that? Why can't the library just take care of all this stuff for me? And
yeah, they have quite the strong statement on their page. Indexes are not needed, ! Not having them makes things easier. Convince us otherwise. A very come at me, bro kind of thing there. And I can kind of agree. And I do agree that indexes are literally a whole part of teaching pandas and managing them and re-indexing.
Yeah, just when Polars was coming out and I was getting used to it, there's a guy who's just a real kind of Python and pandas expert, and he released a basically 2-hour YouTube video talking about how to manage indexes. And I thought, this is the peak of pandas really, that you need like a couple hours just to think about managing the index when you can use something else where that skill just disappears.
Yeah.
Actually, around that time I tweeted, I was just so excited with the way things were going that I could just see like the intern shaming the kind of lead senior data scientist because they're using these new things, and all this knowledge you build up about how to manage these indexes just kind of like disappears overnight, and your intern's using a faster tool than you are and not having to use all this experience that you've won by hard work.
Yeah, definitely. Yeah, but tools change. One of the things that you have on your site is a set of predictions, sort of core predictions as a particular post for core technologies in data science ecosystem. And the first one you had was that Polars And you include DuckDB in that, replacing pandas as core tools for tabular data. That would be your first prediction.
Mm-hmm.
How do you see it going so far? Like, I don't even know the age of polars. I didn't dig into DuckDB in my little background research. I spent more time with Arrow.
Yeah, so DuckDB is another great library. And so I think DuckDB started around 2018, 2019 maybe, and came out of... So I was tweeting about this a few months ago, actually, that there's DuckDB and Polars, and they both come out of either personal or academic projects in the Netherlands, which when we think of all the kind of billions of dollars funded into data analytics, that the two most exciting tools are really coming out of kind of this kind of open source world.
Yeah.
So it's come out of like a database research group, whereas Polars was created by a guy called Richie Vink, who's really the kind of driving force behind the project. And my understanding is that he was really interested in Arrow, and he was a Rust developer doing some data engineering, and then he just wanted a Rust DataFrame library. And that's kind of one of the key things to understand, is that I kind of think of pandas as being like a Python library with C extensions, where there's kind of like a core bit of logic, and a good bit of that is in Python, and then it calls C for the kind of computationally expensive bit.
Yes.
But if you go into the Polar source code, you see that the Python aspect is really more like an API, that a typical kind of Python function in Polars will maybe parse the arguments a little bit, but very quickly it's passed down into the Rust layer to do all the core logic there.
Okay, so like a percentage-wise, the division is more like 10% to 90% versus what in pandas is a lot more initial Python?
Yeah, so I guess if you ever have pandas and you say you type in the wrong kind of column name and it gives you an error and you're debugging it, that you go through different layers of the stack there before you but whereas in Polars that doesn't ever really happen. That maybe you got one or two calls in Python, but sort of pretty often you're just going straight into Rust.
Okay. And you've done a little bit of work in contributing to Polars. What's been your involvement with that?
Yeah, so I've done a little bit of work. So I've, when I started getting involved, that I've no background in Rust. And so, as I'm saying, that it's not a library where if you've got a lot of Python experience that you're going to write any of the core logic, because all that sits in Rust. And I was like, this library is great, but what it needs is more documentation. And I think all libraries kind of struggle with getting people to write documentation. But for me, it was like, well, I can't actually write the Rust, so let's see what I can do.
Cool.
So it's been really helpful for me because I've been writing this course, and I basically have to go through the library function by function and be like, oh, what does this function do? Okay, and I write some examples, and my aim is to make sure that every function in there, if you do look in the doc strings, has an example in Python. And so it's been a really amazing learning experience because I've used pandas for years, but if you're busy, you're working on projects, you're working on deadlines, you don't always have time to stand back and kind of keep learning.
Yeah.
But this has been an amazing learning experience that almost every single time I've done a dive through those functions, I find some functionality that I never knew before, and then it's straight onto my blog or onto Twitter or LinkedIn to kind of be like, hey guys, this is cool. I never knew you could do this. So.
That's fun. That's a fun way to share and also contribute. That we've talked about that so many times on the show, that if you want to contribute to open source documentation, just even getting started with it is great. And then in this case, that's another refrain, like learning how to teach something to somebody else makes you learn it so much faster. And then having the people involved in the project being able to say, hey, I'm working on your documentation and I have a question about this, like that must be nice too. As somebody, as a teacher, you don't always get that ability to loop that person in. So that's really nice.
Yeah, and there's an interesting kind of question there, that if you're producing this kind of material, that how do you decide, okay, what am I going to do basically for free and put into the repo, and what do you kind of need to have in your course? And the philosophy that I'm trying to follow is that, what you have in the course, it's not about you've got all this like juicy stuff that isn't available for free. It's about having it really set out nicely in a coherent kind of format and have everything all worked out with exercises.
Yeah.
So that's why I've been able to write so many blog posts, because I'm just like, I don't need to kind of worry that, oh my God, I got to keep all these secrets to myself. That's trying, for me, that driving adoption of the library and showing how amazing it is, that's great for my course. And so that's why I'm kind of so focused on making sure that I'm not just working on my stuff, but I'm helping the library.
Yeah, that's awesome.
So the current thing I'm working on actually is I wrote a quick start guide for my course, like the lesson number 1. Here's like the 4 kind of big ideas.
Yeah.
I'm now kind of trying to get that merged into the library, into the user guide. So it'll be something like 10 minutes to polars. Here you go. If you want 10 minutes to understand what the big idea is and why this is so special, that you'll be able to do that, not in the course, but actually just there for everyone in the in the user guide in the library.
Yeah, maybe we should talk about some of those now. We could kind of dig in. Definitely one of the first things that kind of harnessing some of that speed are these sort of modes that allow you to either, I don't know, I guess it's easiest just to name them, eager mode versus lazy mode.
Mm-hmm.
I'm a little intrigued by them, and I don't know if you could kind of define what they are and when you would use one over the other.
Sure. So in eager mode is, you imagine you've got 5 lines of code. The first one reads the CSV. The second one, say, converts a timestamp into a date. And then the third one takes a group by of the date and gets the daily average. That if you're working in eager mode, that sort of Python comes along, runs the first line, sort of reads the CSV, outputs a data frame, and then it takes the second line, takes that data frame, adds a column, outputs a new data frame, and it's just doing everything really line by line, and it's not looking further down your code to see what happens there. When you work in lazy mode, what you're really doing with line by line in your code is building up a graph of operations.
Okay.
And so what happens is, if you work in lazy mode, instead of just doing in polars a read CSV, you do what's called a scan CSV. And so scan says, hey, polars, don't actually read this file, just kind of start one of these query graphs that starts with reading the CSV file. And then you do the transformation, and then you do the group by. That in each stage, when you add a new operation into that query graph, polars has a built-in query optimizer. And what it'll do is take the current query graph and go back through and look and see if it can find any optimizations. So a classic one in that case is that you've got a CSV file and you're doing a group by. But say you're grouping by one column and then taking the mean of another column. But say there's 10 or 100 columns in your CSV that you don't need those other 8 or 98 columns. So the first thing it'll do in lazy mode is say, okay, when we read the CSV, as we're kind of parsing it line by line, we're actually only going to select the 2 rows we're interested in. So obviously it has to read the full line because it's text, it's CSV. You can't just pull out the column. But it'll do that, but then it'll only actually accumulate the 2 columns that you're interested in.
So there's so much less in memory.
Yeah. So it's one of the things I kind of teach about query optimization, is that a lot of query optimization, because it sounds kind of amazing when you first hear about it, but a lot of it isn't magic. It's stuff that you could do. Often it's something you could do by yourself, but A, you have to remember to do it. Or no, A, you have to know it exists. B, you have to remember to do it. And C, you have to implement it correctly.
Right.
And so
you could have written all that code, and that sort of optimization would be entirely manual steps in your code there. So that's
occasionally it's more advanced, like maybe it does some nice bit of caching or something in the middle or something like that, but that's like the core idea. And what I find is often it's really handy, because when I'm working on a query, that it might start off with a small data set or like with a simple problem, but it kind of gets longer and longer as you kind of get more into it and realize what's happening. But then you don't always remember to go back to the start and be like, okay, now I've got to tell it only to read these columns from a CSV or something. So it's great just to have all that built in. So you just take the pressure off you and let the computer kind of do some of that stuff.
I know that the statements for reading and say CSV, in this case, scanning a CSV, scan underscore CSV, requires an extra step at the bottom, which feels very async IO in naming. It's a collect sort of command.
Yeah.
What's that doing?
So collect tells polars, okay, now it's time to take your optimized query graph and actually run it and give you the output.
Okay. And how's that different from fetch?
So fetch is the equivalent of like a limit statement in SQL. So fetch is saying, okay, we only need 3 rows of the output.
Okay.
So you imagine if you got a group by and you finish it with a fetch of 3 rows instead of collect, that it'll basically parse the CSV until it's found 3 kind of distinct group by keys, and then it'll sort of just run it from there.
Okay.
So that's like a debugging and development tool.
Yeah, like a data, when you're trying to learn about your data set kind of tool. Okay. Do you want to learn Python in just 3 hours? You can get on-demand access to Anaconda's data science experts. Join Anaconda Learning to learn machine learning, data visualizations, data analytics, and so much more. No matter your experience level, learn through hands-on experimentation, and you'll be predicting the future with machine learning models in no time. Make a Nucleus account at anaconda.cloud today to get started with Anaconda learning. So one of the things that it does is it harnesses Apache Arrow, and I was very confused as to what Apache Arrow was initially, partly because there's a lot of stuff happening in the data science space, which is great. There's a lot of interest and energy coming into this industry.
Mm-hmm. Mm-hmm.
I got kind of mixed up with like what Parquet does versus what Apache Arrow does, and maybe clarify that for us a little bit.
Yeah, so I think one of the challenges with Apache Arrow is that it's not necessarily written to be like the public-facing part of everything. So there's not the same emphasis on documentation, I think, and it's very much for kind of data engineering kind of experts. And one of the great things Polars does is kind of hide a lot of that behind the scenes. But
yeah,
I would say with Arrow that there's the key thing to know is that it's really two things. On one hand, it's a specification for how you store tabular data in memory. So it tells you things like how to, like, if you got like 64-bit floats or 32-bit floats, how to like arrange that, like, and pack your bits and so on, so that it's really optimized for modern like CPUs and caches and so on.
Yeah. Okay.
So on one hand, there's a document out there that's a specification that says if you meet the specification, then you can say that this is an Arrow kind of Arrow memory format. On the other hand, it's a set of libraries that implement that format. So if you go to the Apache Arrow GitHub repo, you'll see that there is like the documentation there about the specification, but there's also a lot of directories there for C++, Python, Rust, JavaScript, and so on.
Okay.
And the other kind of key point to note is that those are the official kind of libraries for Apache Arrow that are part of the kind of Apache Arrow project. But you can also create your own library in one of those languages. And if it meets the specification, then you can also say, okay, well, this is also an Arrow library. And as it happens, that the Arrow library that Polars is built on kind of is based on that some of the Rust Arrow people felt that the official implementation wasn't optimized for their needs. And so they started their own kind of Arrow repo that Polars is built on.
Okay. To sort of help continue to optimize it much more for Rust.
Mm-hmm.
Yeah. So the key idea there that it's really not a file format, it's more of a format for how data is going to be held in memory.
Yeah, so it's setting out sort of sensible things like how things, as I said, how kind of numerical data is stored so that it really reads through the cache very efficiently. It also has a kind of more sane, kind of unified plan for handling missing data.
Okay.
Because one of the challenges with pandas is that missing data can be a bit different depending on the type of the column.
Yeah.
Whereas in Arrow, missing data is null, just for everything. And you kind of nans for a floating point, but that's kind of like a separate concept.
Yeah, and I'm intrigued by one other thing about it, that when Arrow objects are read into memory, they're immutable.
Mm-hmm.
Is that different from pandas? How it would handle it normally?
Good question. I think it's complicated. I've asked some of the core devs on this a little bit, and I think in general, Arrow data is immutable. I think there are cases in Rust where that doesn't always hold, but I'm not the expert, so I would say check your local Rust vendor for that.
Okay, yeah. These are comments, I think, mainly from the Arrow pages. They were sort of trumpeting the idea that it's possible to use them in multi-threaded scenarios without worrying about synchronization of that data frame because it is immutable.
Yeah. So I guess, yeah, I do find I've never had any issues with that. And that it's also this idea that it's Apache Arrow is kind of like a Rosetta Stone, that it kind of implements this idea of zero copy, which means that sort of processes, things that are happening in different processes can read into the same objects. And so if you think about Polars has parallelization, but because it's all kind of Polars, it uses multi-threading. So you got one process happening on your computer, and then you got a bunch of different threads kind of all working off the same memory format. But then you can pass things off to something happening in Python or something happening in R or something happening in C++, and they can read into the same object without that. Typically, when you've got different processes, they have to copy the actual data into that process. But if you're working with Arrow objects, you can have these different objects all actually working off the same thing. And so that's one demonstration I've been doing, is that if you have Polars and there's something that, say, you like DuckDB doing, that DuckDB can also support Arrow, that you can then just like call DuckDB for doing that operation and then like continue in Polars, and you don't have to copy your data over to DuckDB.
So give me a little more background on DuckDB.
So the tagline for DuckDB is that it's SQLite for analytics.
Oh, okay. All right. I'm thinking it was SQL-like in the sense that you could store it as a single file, or is it different from that?
It's partly that, although most people would use Parquet for DuckDB rather than, I think, its own data file format.
Okay.
And the other point is that it's column oriented. So a traditional database, MySQL, SQL Server, Postgres, SQLite, that the data is stored row by row,
Yeah.
which is great for when you've got this kind of transactional data coming through, but is inefficient when you're doing group bys and joins and analytics. So the idea of DuckDB was that it would be like SQLite, but it'd be column oriented. So it's much faster for analytics. And so part of the point of that is that it's a single binary. It's not that you can deploy, that you don't need to have like a Postgres or SQL server where there's like a server and then you have to kind of log into it as a client, that it's just actually a file that you can run.
Okay. Yeah, that's what I was wondering about, is like how it's managed and how you would share that database as a DuckDB.
So one point we kind of touched on there was the interaction between Arrow and Parquet.
Okay.
And so Arrow was kind of an idea of started by a guy called Wes McKinney, who's kind of well known as the creator of pandas.
Yeah.
And he was frustrated with the kind of limitations of NumPy as a backend for tabular data. So he started the Apache Arrow project as being like, okay, well, let's learn all the lessons of the last kind of 10 years, the first 10 years of the data science revolution and try to think about what the best practices would be. So he started this Apache Arrow project, and kind of in tandem, people were working on the Parquet project, which is also an Apache project, and the kind of two projects co-evolve. And you can kind of think of a Parquet file as being a compressed representation of data on disk, and Arrow as being like the uncompressed representation of that data as a tabular kind of data frame.
Okay. So one's as a file, and it has the optimizations as far as that was one of the things about CSVs that's sort of, they can be rather large because they are just pure text.
Mm-hmm.
There's no optimization for, okay, this could be this type of data format that could be then somehow data compressed inside of it. CSVs generally are not compressed.
Yeah, so there's the kind of three key differences from a CSV, that a CSV is text for one thing.
Yeah.
Whereas a Parquet or Arrow, they're actually representing the stuff in floats or strings, whatever is binary. Secondly, Arrow and Parquet have columns with a distinct D type. And then third, that you've got this kind of column name so that you can then just reference everything. So they're stored in columns, and you have a column name for everything, and it has a D type so that you can just store it on disk with that D type and that name, and you can just pull it straight out like that.
That's interesting. That's where I've heard Arrow the most, is seeing it being added to pandas. So that is a direct result from Wes McKinney's effort there. So that's really kind of cool that he's also looking at other ways to kind of move things forward there.
Mm-hmm.
That's your second prediction, right? That Arrow will be the core technology in data science ecosystem.
Yeah, and so we're starting to see a little bit like that. I guess in the data science ecosystem, in the tabular data science ecosystem.
Okay.
Because it's really, at the moment, we have kind of NumPy, and NumPy arrays can do a lot of things. Like people work with computer vision data sets, or they work with NLP, or they work with tabular data sets or time series. But I think there's more of a distinction between, okay, NumPy is really good at some things, but it's kind of hard to adapt to some of the tabular problems. And so for tabular data, you really have Arrow as being the default representation, and then you'll have NumPy kind of more back in its own speciality of kind of more numerical computing.
Yeah, that's something that I think you're still going to need. And I've seen in some of the tutorials that you've created, generating data or kind of creating examples. NumPy is still a great tool for creating that sort of stuff. It has a lot of those methods ready to go.
Yeah, and as a kind of, like in general, like anything where you're doing linear algebra, like one thing that struck me is that, since pandas came along, that PyTorch was started, TensorFlow was started, and they both reinvented their own kind of data format, but they all invented something that looks a lot more like a NumPy array in their kind of their tensors, that they didn't, when they started with a blank sheet of paper, that they didn't invent something like Arrow, because that's not what you need when you're doing lots of linear algebra or scientific computing. You need something that looks like NumPy.
Okay. And then the third prediction that you had is sort of generally just called rustification. And we've definitely talked about that here and have seen, well, I have said this, I think, several times now, about how I asked this common question about what do you want to learn next? And it doesn't have to be about programming or anything about Python specifically. And the most common answer I've gotten in the last 3 years is, I want to learn Rust. And so a lot of Python people that are involved in open source, the type of people that I would bring on this show that are interested in, they're writing books or involved in teaching other people like what's going on, in the Python community, they're all very interested in it. And I'm kind of fascinated by that in many ways. Like, why do you think that is?
For me, I think the attraction is because that it has the kind of, one hand, the tooling, that you've got the kind of cargo kind of thing there that works a bit like pip, that you can manage these crates. And that, I think my experience working with kind of the brief forays I've had into working with C and C++ is that it feels like you're back like when I was doing my PhD, where you kind of you're kind of left to manage a lot of that stuff yourself. Whereas it feels a lot kind of more safe knowing that you're kind of in a world where you can look things up you can just install these other packages like you can with pip or npm or something, and that you're just plugging into that ecosystem, and that you're not like slaving away implementing something which actually exists in some package that you have to just know the right kind of website to actually find and things like that. So,
and there's really one way to do that. They've built on the shoulders of all these other struggles over time for languages to figure it out, especially Python's long story with packaging. That they were like, right away, we're going to have a packaging solution.
Because I did my PhD in oceanography, and for most of my PhD, we used MATLAB.
Okay.
And then I got kind of switched into Python. And one of the major differences was, like for MATLAB's great at actually running a lot of calculations. But the problem with MATLAB was that there was very little element of community development. That you really had kind of 100 PhD students writing like 100 versions of the same code in 100 different offices. Whereas when we went into kind of Python world, suddenly you had projects like Xarray, which was really came out of the kind of climate community, where suddenly it felt like everyone was working together.
Do you feel like the Rust community is built up pretty strongly already? Or does it depend on, are there certain fields?
I think it's still very early stages. Like I was just looking this week to see like what developments there have been in terms of machine learning libraries, and it's still early days in terms of that. But I'm wondering if you have a library like Polars will kind of be more of an anchor point for people to really build more of a kind of data science infrastructure around things.
And that is kind of a unique thing, that this library is written to run in both Python and Rust, right?
Well, it's got other APIs. You can actually use it for Node as well. And that there's also an effort towards a WebAssembly API as well, that when it's really a Rust library, and then you can just add on your kind of API from wherever, that because the API is, I say it's a relatively thin layer, so it doesn't actually take a huge amount of effort to, obviously it's not a trivial amount of effort, but to write it for a new language is really just doing the API. You don't have to really do much of the core logic again.
Oh yeah, that's going to save a lot of effort if somebody's done that heavy lifting for you. That's great. Where else are you seeing rustification?
I think it's with the exciting bit for me about that is that occasionally when I'm working with clients, that there'll be some kind of nasty algorithm that they want me to implement, and then that's where things often get slow if you're reduced down to writing kind of loops in Python, and you can do things like write number and stuff to speed it up. But what I see the attraction is, and I see this a lot on the Discord of Polars, is that people who are writing in Python, but they want to just write that one bottleneck function in Rust. And then it's actually really easy to then just call that in your Python code. So at various points in my PhD, I was thinking, I've got a bottleneck here. I might write this like C or C++ extension. And you look into it and people are basically saying, don't do this, like on a blog post, unless you really have to, because it was such it's not a simple process. Whereas to write a Rust extension is much more about just learning how to write that bit of Rust code. It's pretty easy to actually bring that into your Python code.
Comparatively to diving into C and figuring out how to integrate all of that.
Yeah, big time.
That's great. Yeah, I keep hearing it, and I definitely see it on the horizon myself. I'm interested in kind of learning some of it. I don't have a project in mind, but I've talked to I don't know how many people now, and they're all got little projects where they're trying to figure out ways to do that, and I think that's great. I mean, I think it's sort of a form of abstraction in a way, letting Python still be Python.
Yeah, I'm seeing a bunch of people actually use Polars as their excuse to kind of try out something in Rust, because the API is so similar between Python and Rust, and the Python API is better documented. So you can look at that and look at some Rust examples, and then it's a kind of safe space to get into something and do and kind of work with the kind of data you're familiar with working with.
Yeah. This week, I want to shine a spotlight on another Real Python video course. It's tangentially related to this week's conversation about working with DataFrames, and showcases a data visualization library with a unique approach. It's titled Graph Your Data with Python and ggplot. The course is based on a Real Python tutorial by Miguel Garcia. And in the video lessons, previous guest and core team member Martin Broyce shows you how to install the library Plot9 and Jupyter Notebook. Use Plot9 to create visualizations in an efficient and consistent way. Combine the different elements of the grammar of graphics, which involve several layers, including a data layer, aesthetics layer, geometric objects layer, and several additional layers within that grammar. You'll learn how to perform statistical transformations, how to implement a visual style with themes, and export your data visualization to files. Data visualization is a crucial step towards sharing your results and findings, and I think this course is a worthy investment of your time. Real Python video courses are broken into easily consumable sections, and where needed, include code examples for the techniques shown. All lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com. One of the other areas that you have on your predictions is not a prediction, but sort of a question. And it's, well, what do you think about GPUs? And that's been kind of a rallying cry for a long time here is, oh, we'll just throw GPUs at the problem in the data science community.
Mm-hmm.
Do you feel that that's slightly different if we have new libraries and new tools? Because I always think about that, like, what are the solutions for somebody who, just has a home computer or a laptop?
Yeah, so because I interact with some people on Twitter, and they're like, Polars is pretty fast, but if you use like one of the GPUs libraries, it is faster. It's not actually kind of enormous difference, but it is faster to use the GPUs. But I think from my experience of having worked and deployed kind of the machine learning projects, that it's not just the fact you have to go out and buy the GPU and then you need to be utilizing it. It's even from a deployment perspective, it's like, okay, does that mean we can't just run everything on this one kind of EC2 instance? We now have to like provision this separate expensive GPU instance and like do all this extra kind of stuff. Like you just end up with this organizational complexity to having to manage GPUs in some of these production scenarios that are even more so if you're going into work on premises for a client and they're like, oh God, we just bought this new server. Don't come and say like we need to go and buy a bunch of GPUs for thousands of pounds or dollars, whatever, to just make it work on the CPUs. So I think it's just, if every laptop came with a good kind of GPU, then I think that process would be much more advanced. But I feel like GPUs will still be very dominant at the high end of the market, but kind of for the broad spectrum, it's still going to be kind of cost and effective on a kind of total cost basis to push for GPUs, especially with these new libraries making such better use of the whole range of CPUs.
Right. And being able to do things like the lazy mode to kind of take advantage of a lot of the libraries were not even really doing multi-processing, not using a lot of this stuff. So that just getting that sort of efficiency there.
Yeah, because I've worked on problems where I've needed a lot of memory, and so I've gone and got a big EC2 instance on AWS to run something which needed a lot of memory. But I was kind of embarrassed looking at the CPU utilization with pandas because I was just using one CPU. It's coming with 30 odd virtual CPUs, and barely anything is actually running. So I think you kind of get a different cost trade-off once you're actually using all those CPUs as well as the memory.
This is a very specific question, but I'm in the Apple's ecosystem, and they've been building some very interesting new ARM-style chips that have kind of unique GPUs that I think have to be written, library-wise to take advantage of them. I don't know if you know anything about Polars and how it runs on, say, the M1 series or even the M2s now.
Oh no, good question. I'm going to put that out to the community.
Yeah, because
I think I've seen people say it runs, but that's about as far as I know.
Yeah, I'd like to see it, taking advantage of those cores, and I know it requires knowledge beyond my to get into that sort of stuff. So
Yeah, but it's interesting because obviously we don't have all of your high-end workstations. So I made a YouTube video last week where I was trying to show the kind of the streaming capabilities of Polars. And so streaming is basically working with larger than memory data sets.
Yeah.
So it's where you process your data in small batches, even if it's a big data set. And so I was trying to illustrate it, but I also have a pretty nice MacBook Pro with 32 gigabytes of RAM. And I was trying to illustrate this, but the problem is that on this laptop, it's kind of hard to run out of memory. That you can need a big data set to run out of memory and with Polars and then I remembered that one of my clients has given me a kind of a much more kind of typical corporate laptop, a Windows laptop with
what gets issued, if you will.
Exactly, yeah, with 8 gigabytes of RAM, and it's running Windows, so a bunch of that RAM is gone even before you start it. So I was like, well, this is like a much better use case. So I took that laptop out and we showed that I could process like tens of gigabytes of data in a couple of minutes on a laptop like that without running out of steam. And the nice thing was that it uses the lazy mode.
Yeah.
So you build up your query and then you just pass a single argument to that collect statement, to that evaluation statement at the end, saying, okay, use streaming. And then suddenly Polars takes care of the rest, and it processed just that huge amount of data, made the fans whir in a satisfying way for a couple minutes, and out you get.
So maybe you could say, like, what were the sizes then? You mentioned the size of the memory inside of the laptop, which is 8 gigs minus whatever else you have running, operating system and whatever. And how big was the data set?
Dataset was 30 gigs of CSVs.
So it had to glue all those CSVs sort of together and read across them. And the fact that it could do it through streaming, it was still able to accomplish it even on this kind of, issued laptop.
Yeah, so the kind of core idea is that to implement that kind of thing, you have to implement it on an algorithm level. So if you imagine you're doing a group by in a column and taking the mean of another column, that if you're working in these kind of batches, you can't obviously just take the mean of all the mini batches and then average them out. So you adapt your algorithm so that for each batch, you take the sum of the column you're interested in and the count of how many records, and then you kind of pass all those through to the end and then sort of add up all the sums, add up all the counts, divide them to get the mean. So what's happened with Polars is that Richie Vink kind of decided he wanted to make Polars streaming in September. And all through October and by early November, that for those core algorithms, he had made that happen so that you can actually kind of run these huge data sets. And that all happened in the space of about 6 weeks, which is really remarkable.
Yeah, to implement streaming, that's pretty impressive. Are there other experiments that you've tried with that?
Yeah, so everything I've worked have tried. So you can do these huge joins. If you got to do a big cross join or something like that it really doesn't matter because it's just going to see how many kind of CPUs you have and then just set the number of batches and then it'll kind of just run things through like that. So
cool.
It kind of takes a lot of the pressure away, and you think about how kind of cost effective that would be if you're paying on the cloud, especially for your maximum memory usage, and you can kind of say, okay, well, let's just take a bit more of cheap CPU time and a lot less expensive memory. Then that becomes quite attractive.
Well, I feel like sometimes as a data scientist, you might be surprised by a project, like you're initially going into it, and you're like, oh wow, okay, I suddenly have this huge amount of data. I wasn't prepared for that. And the idea of having to go and source something online or whatever, you may say, oh, that's just trivial. I'll just, do whatever. So I don't know. I don't know how you are with AWS, but all of it seems to take a certain amount of time that is a little frustrating because it's not your skill set, per se. The idea to be able to just continue running it on the machine that you have is great.
Even the other story I hear a lot is that not necessarily you have to go to the cloud, but that things just got too big for pandas, and so people are like, "Oh, we had to just start using Spark." They had this, and then suddenly there was all this like infrastructure complexity that what you really want is a tool that you can use for tiny data sets, and then as that data grows and accumulates, you can then just be like, "Okay, let's just run it in the bigger mode."
So, what would be examples of that, like where you're starting to eclipse what Pandas was able to do, and they were moving into Spark?
Well, I'd say from my own experience, during my PhD, my PhD was in oceanography.
Yeah.
And I combined some observational work where I went out in the ship and then some computer simulations where I ran a kind of climate model to see kind of what happened in certain scenarios. And actually, I thought it was going to be kind of a combination of both, but I went on my first research cruise in the North Atlantic, 37 days. And by day 2, I was like, oh my God, this is not the life for me. That, you see some beautiful stuff out there. You might have some dolphins popping by at lunchtime, but yeah, that's a pretty intense way to spend. I kind of tell people
you got to be into that life.
Yeah, exactly. That if you think of those weeks of work that kind of seem like they go on forever, that was like a 37-day week of work that where you're at work for like 16 hours a day and maybe sleeping like 4 hours a night and being rocked around in your bed for that time. So then I came back off the ship and I was like, I think I'll focus on the simulations actually and leave this to these guys. But in that case, you start off with a kind of what you say, a low resolution model that's working on a very coarse grid. And then as your results start coming through, classic scientific process, you start increasing the resolution, you start increasing the kind of the scope of what you're doing. And then each time you do that, suddenly your data is increasing by a factor of 8. You do that 2 or 3 times and suddenly your nice little problem at the start has now become essentially a data engineering problem by the end.
Yeah. It's nice to be able to have something that might be more elastic in that way, let it expand a little bit so you don't have to quite jump into that, because that's a hard part for a lot of people. I mean, even just having this conversation with you, it's like, okay, here are a bunch of new tools. Primarily, though, we've mentioned them to get into polars. You don't necessarily need to know all of what's happening with Apache Arrow. That's really kind of under the hood. And you can still be working with CSVs, as we've mentioned, though if you're storing them yourself, you may want to look at something like Parquet. I thought even just pip installing it was like faster. It was like one line.
Well, no, but that's not a coincidence. I think one thing that you kind of really clear working with Richie and seeing how he thinks is that keeping the binary small is like one of the goals of the library, because of that, the size of the package. Like, because people come along to the Discord and they're like, oh, it'd be nice if we could have this, or this. And it's saying, well, you can do that. It's maybe 2 commands at the moment and your thing would add 1, but each of these things adds a bit more code on. And that just kind of becomes a sort of bloated binary over time. So part of that, I think, is that it's nice just to have a small binary, and also thinking about things like WebAssembly, that if you're running things in a browser and you've got like 100 megabyte binary, that's going to slow things down a lot. Whereas if you've got a 10 megabyte binary, then, that's going to be a much nicer user experience.
Did you hear the recent news that they've basically sort of distilled MicroPython to run in WebAssembly?
Oh, nice.
It's like 300 kilobytes, something like that. It's much, much smaller. I'll have to look up that number for sure, but it's beyond what was like, well, you got to load, 20 megabytes or whatever it was.
Well, this is the kind of the philosophy that's made SQLite so successful for 20 years of having this kind of real focus on efficiency and keeping your binary tight, and that has a lot of benefits.
Yeah, it seems like he subscribes to that. Are there points that have missed that you want to focus on?
Yeah, so I was going to talk about the interaction with the development of the ecosystem. So we kind of touched on that briefly, but I've been surprised how well it fits into the ecosystem. So using something like matplotlib, I was thinking, matplotlib, is that really like a NumPy kind of ecosystem thing? And what's it going to think if I pass a column from a Polar's data frame?
Yeah, isn't it kind of even integrated in some ways with pandas, talking about the size of its library?
Yeah, well, but this is what I found, is that we don't actually need that integration, because what matplotlib actually wants is just something you can iterate over.
Okay.
So it just wants a sequence. So if that's an arrow, kind of a column of an arrow table, or a column in a Polar's data frame equivalently, that's what it gets, and it's happy with that. Same with plotly, that if you pass it a column from DataFrame, it'll go and plot it, and it's quite happy to do that.
Oh, nice.
And so there's an exciting kind of development happening called these kind of interoperability API. So it's the idea that for all the DataFrame libraries, so pandas and CUDA and polars, that they'll have this kind of like methods there that if you're a plotly and you got an object coming in, you can check if it's pandas. But if it's not pandas, you can say, well, does it have this DataFrame namespace in its methods? And if it does, then it can just use those and know that it'll get something that it expects to.
So it would have like a similar footprint, so they all kind of match.
Yeah. So all these ecosystem kind of libraries don't have to think, right, do I need something for pandas, and I have to adjust for polars and so on, that they can just work with this DataFrame namespace and then be able to kind of work all happily together.
So that's all kind of data visualizations you mentioned there. Are there other places that would come into play?
Yeah, so there's a similar project happening for arrays. So this array API, so that if you've got NumPy or you've got other kind of like PyTorch kind of tensor kind of thing, that you could use you could apply the same operations on all of them. That by just using the same API, and if it doesn't find that it's a NumPy thing, it just checks to see if this API namespace is there, and then just does its operations on that instead.
Oh, great. Yeah, it sounds like it's very forward thinking. Needs to play well with others is
Yeah, and I think it's great that like pandas was one of the first to adopt it.
Yeah.
And as the kind of dominant library, that when they adopt it, it means that everyone else can do it as well, and know that it's a really good investment of their time to improve this interoperability.
Yeah.
And the other thing I see arriving this year is kind of support from the machine learning libraries. So XGBoost now accepts arrow tables, and I did a blog post about that to say that you can have your data in polars, and that underneath the hood, in the same way that underneath the hood of a pandas data frame, you've got a NumPy array. Underneath the hood of a polars data frame, you've got an arrow table, and you can just pass that arrow table directly into XGBoost and into TensorFlow as well for tabular problems.
That's great.
So I was going to say, if people want to get involved, my kind of recommendations, first thing I would say is just pip install polars, conda install, whatever you like, and just actually play around with it. Check out the official documents and the user guide. I've also, on my blog, there's also a quick start notebook that you can load up in Colab online straight away and play around with things. If you get stuck, we really like people asking questions on Stack Overflow. That a lot of the community really monitor that very closely, and you often get an answer within a few hours. And we really like to kind of build that out as a kind of support mechanism for as the community develops.
Yeah, definitely. Common place people go.
Yeah, you can join the Discord, get talking about the kind of concepts and the kind of use cases, and we love to kind of see what people are using it for and hear about that. And then if you find a bug, then feel free to kind of raise an issue and sort of set out some kind of minimal example of what's going on, and we'll kind of think how it works. And if you want to go beyond that, then I would say write some documentation and do a pull request based on that.
One of the things that I noticed, we've talked a lot about pandas lately in how people like Matt Harrison and other people have been using it. He was a previous guest on the show, and we were talking about chaining. And I feel like based on a lot of the examples I saw, not only in the documentation, but also the ones that you were creating, that seems to be pretty common as far as the way that it's set up in polars too, that it's sort of a little bit chaining first.
Yeah, definitely chaining first. And part of that is because of the way the API is developed, that you can't kind of create new column the same way that you can in pandas, that you do use this kind of chaining method. And then part of it is that you're in this lazy mode, and once you use lazy mode, I found that I start thinking about my queries as more of an end-to-end integrated thing. And if you're thinking of your queries as an end-to-end kind of integrated process, then I feel like the chaining method makes much more sense in that way, that you're kind of thinking about all the steps kind of as a sequence.
Yeah. There's some other kind of niceties that are built in. Like I mentioned this to you also right before we began, about how just when you go to print a data frame, it has some niceties like just ready to go. Number one, like if you're working just in a terminal, it goes ahead and does a really nice grid for you automatically. But at the top, it gives you the column names, what those actual column names are, and then their data types. So it's kind of like 3 or 4 different pandas commands that you would have had to type in. I think you even said them. I forget what they were.
Yeah, to get the shape, get the D types, and and see some of the data. Yeah, it's nice. And it's really easy to adjust that stuff. There's a space like pl.config, and then you can just adjust the number of rows, number of columns, and it's really easy to go in and explore that and see what the different options are.
Yeah, it's so nice. Just like ready to go. I mean, there's such common things you see, especially in tutorials, like, okay, let's look at what the D types are. And yeah, so that's kind of some other niceties that are there. Yeah, so I'm excited to start playing with it myself some more. I'll try it out on a few different projects and kind of continue from there. What are good ways that people can follow the work that you do online?
They can connect with me on LinkedIn or follow me on Twitter. I kind of post the same stuff to both. And I'm posting very frequently, so I'm trying to just get all my thoughts out there and kind of just spread the word. So if you follow me, you'll hear a lot about polars and not much else apart from polars at the moment. So
yeah, one of
my colleagues, my old colleagues here in Belfast, said that I was the hype man, and I think that's that has been the case this year. At least I'm doing that.
Definitely true. And people can definitely follow the blog, and I'll include links to all the different resources that we mentioned here.
Yeah, and what I'm hoping to do is make more YouTube videos.
Okay, so keep attention to that channel.
Yeah, it's interesting watching the analytics, that I made some videos back in April and almost nobody watched them for the first few months. And then I just started to see this exponential growth happening around August, September, and suddenly more and more people were watching. So it was just nice to see that I hadn't really done anything, but suddenly you could see that kind of groundswell of interest was happening and people were starting to search on YouTube, because I love YouTube to learn about data and data processing things, especially the new stuff. So I'm hoping to make more stuff on there.
Cool. I have these weekly questions I like to ask everybody. And the first one is, what's something that you're excited about in the world of Python?
It's kind of indirectly Python, but I'm liking Jupytext at the moment for creating books. So for my course, I've just got these like dozens and dozens of Jupyter notebooks.
Okay.
And I like to package it up and make it into a book. And I'm finding this Jupytext thing is great, not just for making a book, but also for version control on notebooks, that you can kind of synchronize a notebook and an accompanying script or markdown file. And so those things don't have the outputs in it, and they're much easier to kind of integrate into Git. And so the philosophy is actually that you don't commit the notebook anymore. You just commit these kind of synchronized files.
Oh, cool.
And so then you can do nice diffs on them and see what's happening. And yeah, it all works really nicely. There's a lot of cool things happening in that Jupyter ecosystem, I'm finding.
Yeah. I've kind of, my eye has not focused on it lately. I haven't been doing too many stories about Jupyter lately, but man, it's a train that just keeps going. And so what's the name again? Is JUPY text?
Text, yeah.
Okay. Nice. That sounds like a great tool.
Mm-hmm.
I almost was thinking you were talking about actually true printing it, but it's much more of an intermediate format than to allow what you were just mentioning.
Mm-hmm. Yeah, yeah.
And then what's something that you want to learn next? This doesn't have to be Python specific.
In kind of data analytics stuff, it's working with cloud storage kind of more effectively, because what I'm finding now with Polars is that the actual, once your stuff's in memory and it's kind of running, that bit is now just really heavily optimized, that a lot of the bottleneck is really now the interaction with your kind of blob storage or S3 or whatever on the cloud. And then what I'd really kind of hoping to see in Polars is that it can kind of do more of taking care of that. So if you've got a bunch of CSVs in the cloud, that you can just write your query and point it to the S3 bucket, and then it'll really hopefully be able to push as many optimizations as possible into the cloud and minimize the amount of data transfer. And I think that kind of sort of remove the bottlenecks for a lot of people.
Yeah, that sounds cool. Well, Liam, thanks so much for coming on the show. It's been really fantastic to talk to you.
Yeah, it's been really fun. I've really enjoyed it.
And don't forget, for all your data science needs, join Anaconda Nucleus, your home for data science in Python. Join at anaconda.cloud to power up skills, innovate, collaborate, and find the perfect Python package. I want to thank Liam Brannigan for coming on the show this week. And I want to thank you for listening to the Real Python Podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python Podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.